Welcome to my video on determining slope of a line and y-intercept using tables and equations. So find the y-intercept in the table, so we can look at the table. Remember, the y-intercept will always be paired with 0 as the x value. And for our purposes this year, our tables will always have an x value of 0 so that we can easily locate the y-intercept. Okay, so right here. So plot the y-intercept on the graph. Okay, so we can plot 0, 1 right here. So that means the y-intercept is 1. It crosses the y-axis at 1. Now, plot the next coordinate from the table on the graph. So we're going to plot the point 1, 3. So I start at the origin when I graph an ordered pair and go 1, 3. And now what I want to do is, starting at the y-intercept, count up or down and over to get the next point on the line. How far up or down goes in the numerator of the slope ratio, and how far over goes in the denominator of the slope ratio. So we only need these 2 points. I know we have a whole table here, but we're not going to graph the whole table. I just need these 2 points because my goal is to find the slope in the y-intercept. So we're just going to go up 2, because I'm starting at the y-intercept. So go up +2 and over +1. So the slope is rise over run. So I rose +2 and I ran +1. And 2 divided by 1 is 2. And my y-intercept, or my b value, was 1. Okay, so we can just connect the dots here so we can show that it's a graph of a line. And I know it's going to go through these other points here. I know it needs to go through -1. I know it needs to go through -2, 3. So I'm just going to make sure I go through those points, and I need to go through 2, 5. But really, my goal here was to show you how to graph from a table. So really, you only need to do 2 points to find the slope. And the y-intercept is when the x is 0. So that's it. I only need to do 2 points. I don't need to make this complete graph. So if you like this strategy, you can use this strategy whenever I give you a table. You can just graph it on grid paper. Now, I won't always give you a coordinate plane like this, but you can certainly make a coordinate plane on a grid paper and use that. You can also use our old school way. Let me review that, and you may want to use our other way. And it's the same concept. We're going to rise. Well, let me show you with these 2 points, because these are the 2 I used on the graph. We're going to rise 2, and we're going to run 1. Remember, it's rise over run. So 2 divided by 1 is 2. And you can also look here to find the y-intercept same way. So you can either, if you like this method, you can use the graphing method, or if you like our old method, you can stick to that too. I just want to make sure you have enough tools to be successful. So let's move on. So it says graph the given table, identify the slope, and y-intercept. So remember, we want to locate the y-intercept first. So I see 0, 1. So I'm going to start right here. And so that means that the y-intercept is 1. So we're going to write b equals 1. And that is the y-intercept. And I always like to circle the y-intercept. And now we're going to graph the next point, which is 1, negative 1. So 1, negative 1. And my rule said start at the y-intercept, so we're going to go down 2 over positive 1. So down negative 2 over positive 1. So the slope is negative 2 over 1. And negative 2 divided by 1 is negative 2. So this number here represents the slope. Now remember what we said? The number in front of the x is always the slope, and then the ending is always the y-intercept. Keep that in mind when we get to the next page. Okay? And number 2, circle, excuse me, got an awful cold. 0, negative 1. So the y-intercept here is negative 1. So we're going to write b equals negative 1. And we know that that represents the y-intercept. I already labeled it over here. And now I'm going to graph the next point, 1, 3. So 1, 3. And I'm going to use those 2 points to find the slope. So rise 4 over 1. So remember, rise 4, run 1, and 4 divided by 1 is 4. Okay, now I forgot to connect the points, so go ahead and get a ruler. And I know negative 1, 5 is one of my points here. And really, I'm just connecting it to make a line. Because the reason I'm doing this strategy is to make it easier to find the slope, to give you another way of doing it. And let's go ahead and connect these points here. And we had 2, negative 3, and then we have negative 1, 3, and then draw your arrows. Okay, notice this one slopes down and we had a negative slope. And notice we had a positive slope here and this one slopes up. Now, certainly, you could do the old school way where you just pick 2. And so you could go here and go plus 4. And then here is plus 1. And you still get the same slope, 4 divided by 1. So this graphing strategy is just another way of finding the slope from a table. Okay, now we have something called Slope-Intercept Form. We have y equals mx plus b. Now remember previously, we had something that looked like this. When we started this unit, we had our xy table, write this down. We had an equation y equals 2x plus 5. And we said to make up your x values, and we always picked negative 1, 0, and 1 unless the number in front of the x was a fraction. And then we plugged our x values in, 2 times negative 1 plus 5, and that gave us our y values. And we graphed it. Well, now we are eventually going to learn how to graph this equation without actually making a table. And so this equation tells us something about the line. So remember the m, we know this from y equals mx, the m represents the slope. And I'm going to circle this because we always circle it on the graph. The b represents the y-intercept. Now, the x and the y values represent any ordered pair on the line. Okay. So now take a look at our equation here. We have y equals 2x plus 5. So if we remember, our slope-intercept form is y equals mx plus b. Our slope is going to be that number in front of the x. So what's the slope here? 2. The variable is m, and we're just going to write down what the slope is. M equals 2. Now the variable for y-intercept is this part here. And this variable is b, and the y-intercept here is 5. And remember, the symbol in front of the number is what determines positive or negative. Since there's a plus here, it's positive 5. If there was a minus here, it would be negative 5. Same thing here. This is positive 2 slope, but if there was a negative in front, it would be a negative 2 slope. Okay, so let's check these examples out. What is the slope and y-intercept of the function y equals negative 4x minus 10? So our slope is the number in front of the x, so we're going to say that that is negative 4. And the ending here is minus 10, so that means it would cross the y-axis at negative 10. Number 2, what is the slope and y-intercept of the function y equals x minus 6? Well, if there's no number in front of the x, I call it a 1. So we're going to put a 1 for the slope. And the ending is the y-intercept. So it ends with minus 6, so therefore y-intercept is negative 6. Number 3, what is the slope and y-intercept of the function? So this time the number in front of the x is 1/2. And there is no ending. There's nothing here. So remember when we learned previously that if there's no ending and we just have a slope in front of the x, then we call that a proportional relationship. And where do proportional relationships always cross? At the origin. So the y-intercept would be 0 if it's going through the origin. Okay, this brings us to example number 4. What is the slope and y-intercept of the function y equals 4? So I brought out a graph here so that we could prove it here. Here's my equation, y equals 4. Now there is no x here. So what is my ending? My ending is 4, so the y-intercept is going to be 4. But if y equals 4, what that means is all the y's are 4. So that means that this is going to create, if all the y's are 4, so let's make all the y's 4. 4, 4, and 4. Now get your ruler, and what kind of a line did this make? Okay, this made a horizontal line. And remember, horizontal lines do not have a rise. So the rise is 0, the run is 1 or negative 1, depending on which direction you go. And 0 divided by negative 1 or 0 divided by 1 is always 0, so the slope is 0. Because you can ski down this. Remember, if we had a vertical line, then that's no slope. You wouldn't be able to ski down. So what's the y-intercept? It crosses the y-axis at 4. Okay, number 5, what is the slope and y-intercept of the function y equals negative 3? So again, if the y is repeating at negative 3, this is going to create a horizontal line through negative 3, which is going to mean that it has what kind of slope if I have a horizontal line? Good, 0. And what point is it going to cross through? It's going to cross through a negative 3. Now, which is an equation for a line with a slope of negative 4 and a y-intercept of 5. So look, negative 4 should be in front of the x, and I see it only in example B. And is the y-intercept 5? It is. So the correct answer is B. Now, what I want you to do is quickly, we'll do more work with this in a future lesson. I want you to look back at number 1. And we decided, now that we've learned y equals mx plus b, we decided that the slope was -2 and the y-intercept is 1. So what do you think the equation for this one would be? Let's write it down. So it's y equals mx plus b. And what did we say the slope was for this one? The slope was -2, so it'd be -2x. And the y-intercept was 1, so it'd be y equals -2x plus 1. Okay, now this one, just find some room here wherever you can. Once again, we have y equals mx plus b. And recall that the slope was 4, so y equals 4x, but it did not go through the origin, so I have an ending, and it went through -1. So the equation is 4x minus 1. Okay, that concludes our notes on determining slope of a line and y-intercept using tables and equations. Feel free to use the graphing method by using grid paper when you do your classwork and homework, or you can, if you like our previous method of finding the slope doing this, that would be fine as well. I hope you have a great day.